Hello and welcome to the Triune Physics aka Physics Bible. Today I want to quickly brush you through this experiment on mechanics based on SSCE WAEC 2025 Physics Alternative B. Alternative B candidates, please take note. These are some of the apparatus mentioned in the white paper. G clamp was mentioned. Okay, then set of masses were mentioned. 350 mass, that's 350 grams, and then we have 300, we have 250, 200, 150. So please, this experiment, you would expect that these masses will be combined or joined together to form simple harmonic motion. So I'm going to explain better as we proceed. You need a stopwatch, you need a meter rule. Okay, so the experiment is WAEC 2025 Physics Practical under mechanics, simple harmonic motion with G clamp. Are we here? Now, based on the procedures and based on the past questions, if you observe on the screen, what is being displayed is the past question, that is 2006 practicals. This is exactly the setup you might be asked to exhibit in 2025 Alternative B Mechanics Physics Practical. So pay attention quickly so that you will gain from this and so that you will perform a very great experiment and obtain the best result in your exams. And that is my prayer for you or wishes for you. So quickly, if you look at the diagram on your screen, you observe that the G clamp is clamped to the table and on the meter rule. So you have been provided with a meter rule, a G clamp, and a set of masses. Clamp the meter rule to the edge of the bench such that 90 centimeters of the meter rule projects from the edges as shown in the diagram above. This means that 10 centimeters will be the point at which you are going to clamp your G clamp, or the part that stretches out from your table, okay, will be 90 centimeters. So 100 centimeters minus 10 will give you 90, so that your masses will now be placed on the 100 centimeter mark. I hope you are following. Ensure that the rule is capable of performing oscillatory motion. So we are asked here to fix a mass M 50 grams at the free end of the rule. But for your practical this year, perhaps you might be asked for this first one, it might be 100 gram mass or 150 gram mass. Are you here? So if it is 150, you are going to combine 100 gram mass and 50 gram mass so that you have 150 gram masses attached at 100 centimeter mark. I hope you are following. So deflect the rule slightly such that it performs vertical oscillation. So the main goal here is to obtain vertical oscillation, that is up and down movement, okay, which will give you a complete cycle. Are you here? So that's the main point here. This experiment is similar to pendulum. I hope you are following. Swinging pendulum. So if you understand that particular experiment, this one should be more easier for you. Number 4, determine the time T for 10 complete oscillations. For these particular practicals, you have been asked to take 10 complete oscillations. So you might be asked for 20 in this year's exams. Just know and understand the differences. So it might be 10, it might be 20. Read your question, follow the instructions, calculate the period T of the oscillations, and evaluate T squared. So you are going to capture T on your table, you are going to capture T squared on your table of values. Are you here? Repeat the procedure for 4 other masses or other values of masses: 100, 150, 200, and 250 gram masses. Now, if you observe, this experiment is meant to be repeated 5 times. So if that is the case, for this year's exam, this 250 is 350, 200 is 300, 150 is 250, 100 is 200. I hope you are following. Then 50 becomes what? 150. Are you following? Yes, that is it. So you are asked, in each case, determine and record the corresponding values of t, period, and period squared. Tabulate your readings. Then you are asked to plot a graph of t squared on the vertical axis against mass, which is m, on the horizontal axis, starting both axes from the origin, which is 0. Determine the slope s of the graph and its intercepts c on the vertical axis. We are going to do that. I am going to see that before we round off. Evaluate k is equal to 4 pi over s. Evaluate k is equal to 4 pi over s. Take pi to be 22 over 7, and then from your graph, determine the period t when m is equal to 180 grams. So we are going to be solving that, and then you are asked to state 2 precautions taken during these practicals and other solutions attached. So please stay with us as I take you through this particular experiment. The experimental procedure is as follows. Number 1, you set up your apparatus, meaning place your G clamp, your meter rule, and whatever. Set them up as seen on the screen. Then adjusting the masses, or replacing or changing or varying the masses. It is the masses you'll be varying, not the length, please. So perhaps the length will be constant while the masses will be varied. I hope you are following. Take note of this. Then oscillation, you are meant to perform simple harmonic motion, and then you are meant to repeat the experiment for 5 times. Alright, for this simple harmonic motion practical, you will need set of masses, your stopwatch, okay? You also need solid tape, you will need meter rule, you will need G clamp. Are you here? This is your solid tape, you will need it. You will need your set of masses from 150 grams to 350 grams for 2025 Alternative B Physics practicals. Are you here? Then this is how you're going to clamp or place your mass. Your mass will be placed at the edge, okay? And then you solid tape it. And then from the edge of the table, at least the point at which is extended from the edge of your table should be 10 centimeters. Please watch your question and follow the instructions. Now, how can you perform this oscillation? You are going to depress the meter rule downward, then depress it downward and release. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You stop. You repeat. Depress, release. Depress, release. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can now record your readings. Please note that I'm going to repeat this twice for each mass, okay? Record your readings. So these are minimal are what you are expected to do during this Alternative B practical or SSCE practical under G clamp, which is simple harmonic motion. Remember, the motion is up and down motion. Take note of the number of oscillation. It might be 10 or 20 oscillations, and it is similar to the swinging pendulum. I hope this is clear. So now let's look at our table of values based on this experiment 2006, based on 50 gram mass, 100, 150, 200, and 250. I told you that this 250 will be 350, 200 will be 300, 150 will be 250, 100 will be 200, and this will be 150. Okay, then if you capture your mass, make sure you capture the what? SI unit. Capture the SI units in bracket. I hope you are following. Capture it, then T1. You are meant to repeat each experiment twice. Okay, for 50-gram mass, which is 150-gram mass, you repeat it twice. You count from 1 to 20 or 1 to 10, as the case might be. Then you record your time. You write it. You repeat the same procedure before changing the mass. I hope you are following. Repeat it twice and then write your time for each. Time might not be the same, okay? Which is why you repeat the experiment for T1 and T2. Then you find the average. The average. So the average becomes T1 plus T2 divided by 2. Is that clear? And then this average will give you, then term this to be T average. Yes, this can be T average. If you obtain this, now also watch your decimal places, 2 decimal places. Okay, for each column, you must make sure that you maintain the standard based on that. If not, you'll be penalized. I hope you are following. Then our T, which is period, is equal to our time over the number of oscillations. For this particular practical, the number of oscillations is 10. This year's own might be 20. So it's going to be your T average, which is this, okay, divided by 10. I hope you are following. If it's 20, it's going to be this divided by 20. You write your answer. This divided by 20, you write. For this is 7.85 divided by 10, you have this. And you continue to have what you have here. I hope you are following. Then T squared, you are going to square this particular value. You square each of these values to obtain your final answer. I hope you are following. If that is the case, we have been told to plot a graph that is under graphical analysis. So plot a graph of T squared, which will be second squared on the vertical axis, against M, which is mass in grams, on the horizontal axis. We have been told to determine the slope S of the graph, find the intercept C on the vertical axis, and then the relationship, if there is any. Standard steps for graph plotting. Standard steps for graph plotting. WAEC students, NECO, NABTEB, GCE. This tutorial is for you. You're going to learn how to plot a standard graph, especially when it comes to your final year exams, so you can obtain the maximum result and marks, because you can be penalized. And if you fail your practical work, automatically, especially like physics, you will fail physics. Practical work is close to 40 marks because you are going to answer 2 questions. Then you should understand that 60 is what is left for OBJ and theory. So please sit up and pay attention to this. Step 1. Choose the correct variables. Choose the correct variables. That's the axis. The independent variables, the one you control, is plotted on the x-axis, as seen being displayed, and from this particular experiment, our masses are on the x-axis. So, and the values are fixed. So we have control over that. We plot that on the x-axis, although it is in the instruction. Are you following? Then, the dependent variable, the one measured, goes on the y-axis. Are you following? So the practical, the experiment carried out, is what will be on the vertical axis. And if you check, we are asked to plot T squared on the vertical axis. Okay? If it is for electricity, it will be V against I, or V inverse against I inverse, or V against R, as the case might be. Then, step 2, choose appropriate scales. Make the graph occupy at least 3/4 of the graph sheet. You can see my graph on this screen. You can see that I tried by all means to extend my graph to both edges. And then you make sure you capture 3/4 of your graph. So it means use almost everything if you want your mark to be given to you perfectly. Use simple scales like 1 centimeters is equal to 1, 2, 5, 10, not 3 or 7. It will be complicated for you. Or you can use 2 centimeters as seen on this graph. What do you see? I'm using 2 centimeters for 0.1 units on the y-axis, and I'm using 50 units for 4 centimeters on the x-axis. Can you see that? Yes, that is it. So never write 0 more than once. Start close to the origin, but not necessarily at origin. The instruction for this practical was that the graph must begin from origin, both axes. So which is why you are saying 0 there. I hope you are following. Then step 3, label the axis clearly. So what does it mean? It means what is plotted must be written or captured, and the SI unit. How to determine the value of each tiny line. This is the procedure. Okay, your 2 centimeters divided by the differences between the upper limit and the lower limit. Okay, like this is 0.2 minus 0.1, which gives you 0.1 divided by 10 lines, 2 centimeters, and this will give you 0.01. Is that taken? 0.01. So each tiny line is 0.01 on the vertical axis. You do the same thing for the horizontal axis, and then for x-axis, which is m, which is mass in grams, we have 4 centimeters, not 2 centimeters, 4 centimeters here. Okay, represents 100 minus 50 units, which will give us 50 units. So how many lines are in between? 10 plus 10, which gives us 20. So it's going to be 4 centimeters is equal to 20 lines, and is equal to 50 divided by 20. Okay, if you do that, our answer becomes 2.5. So each tiny line is 2.5. Take note of this. This will help you in solving problems when it comes to slope, in determining your intercepts, okay, and some special values. Please take note that this is not your scale. Okay, this is not your scale. Now let's proceed. Choosing appropriate scale. Make the graph occupy at least 3/4 of the graph sheet. Okay, then your scale for y and x axis must be captured as seen. For y axis, 0.2 minus 0.1 will give you 0.1. So 2 centimeters is equal to 0.1 units. For x axis, it's going to be 100 minus 50, which gives you 50. So if you want to confirm, you can continue with the same procedure. You see that 50 is constant. So 4 centimeters is equal to 50 units on x axis. This becomes your scale. Use simple scales: 1 centimeters, 2 centimeters, 1, 2, 5, 10 units, not 3 or 7. It will complicate issues for you. The scales on both axes must be uniform. Take note of these. Never write 0 more than once. Start close to the origin, but not necessarily at the origin. Is that clear? Let's proceed. Step 4. Plot all points neatly. When the mass was 50 grams, t squared was 0.48. Now 0.4 to 0.5, that's where 0.48 lies. So for you to know where 0.48 is, you will now pick the difference between 0.4 and 0.5 and divide by the number of lines. Okay, so this can be 10 divided by 0.01. I hope you are following. So this will give us 0.01 times 8 will give us 0.08. If you add that to 0.4, it will give you 0.48. I hope you are getting it. So it means we are going to count 8 lines. So let's begin. In between 0.4 and 0.5, we'll count 8 lines. Let's count now. You see, the center is 5. So 6, 7, 8. So that is a point. All points must be plotted accurately using X or dot with a circle. Okay, I'm using X here to represent that. So pick this point. You may be penalized for using dots without crosses. Is that clear? Take note of that. Or when you plot outside the box lines. Now the second one now, when our mass was 100 grams, our T squared was 0.62. We'll do the same thing. 0.62. So this is 0.6. Okay, I'll just attach 2 lines to it because I know that each line is 0.01. So that becomes our answer. Then the third one, when it was what? 150. 150 gave us what? 0.77. So let's look at our graph. 0.77 is after 0.7 and before 0.8. So that gives us 7 lines. We'll count 7 lines. Yes. And make a small X on it. From 7, you count 7 lines. The center is 5, 6, 7. So this gives us our point. Is that clear? So we'll proceed now to the next value. Our fourth value here is 200 gram mass and is 0.92. Okay. Then if you check 0.92, just 2 lines after 0.9. So this gives us our answer. Okay. Then the next one is 250. 250 is 1.06. So we'll move to 1 and count 6 lines. Are you here? So 250 connected to 6 lines. Can you see it? 6 lines. So we have this. Our answer is around this point. So this gives you the lines of best fit. Now, draw a best fit line or curve. For this, we are going to draw a line. If the points fall on a straight trend, draw a best fit straight line. Is that clear? Pick at least 3. If all the 5 falls in, that is perfectly. Can you see this? You can't use this. Let's pick at least 3. Don't connect dots point to point like a child's puzzle, please. Use a perfect straight line. Can you see it? So this can give us our answer for this. So we can use this. We can go ahead and use this. From here, you can be asked to determine the point of intercept and also the slope. So the point of intercept here, if we are going to calculate for that, the intercept is the point where the line of best fit meets the vertical axis. So this is the point. And if you observe, this 3.5, 0.35, 0.37. Can you see that? 0.37. So that gives us our answer for this vertical axis. And if SI unit is required, gives you T squared or S squared. Our slope is change in Y over change in X, change in T squared over change in M, which is our mass. Okay, then this will give us T squared 2 negative T squared 1. So that becomes our formula. Then how to choose points? Select 2 well-spaced points on the line, not from the table. Okay, clearly show these points with coordinates written beside them. WAEC loves when you show chosen points on the line. That can gain you up to 2 marks. So you can decide to pick any point. I hope you are following on this graph, and it will still give you your perfect answer. So this is a change in Y to change in X. Is that clear? So our change in Y now is 1.06 minus 0.77. Okay, 0.77, all divided by our change in mass will give us what? 250 negative 150. So that this will give us 1.06 negative 0.77 is meant to give us 0.29, all divided by 100. So that this will give us our final answer to be 1.053. That's our slope. Okay, the SIN becomes second squared over grams. Second squared over grams, which is second squared per gram. I hope this is clear. Take note of that. Now, bonus tip. What is the title of this graph? Is T squared. Graph of T squared against M. I hear. But when writing, write graph of T squared in second squared, as in bracket, against M in grams. Exactly. Now, one of the questions is determine T when M is equal to 180. So what we're going to do is that we're going to locate 180 from the graph. 180 is in between 150 and 200. How are you going to do that? If you look at 150 and 200, we have 20 lines. So the differences is 200 negative 150, which is 50. Now 50 divided by 20 lines will give us 2.5. Are you here? So how many 2.5 are we going to add to 150 to obtain 180? Are you here? So you are going to do your mathematics. Your calculator should be close. 2.5 times 10 will give us what? Will give us 25 plus 150 to give us 75. Okay, which is 175. Then 2.5 times 12 will give us 30 plus 150 is 180. So this is perfect. So 12 lines. Okay, so if you attach 12 lines to 150, where are we stopping? Look at it. We'll stop somewhere here. So we're going to use a straight line. Okay, and connect this straight line to our line of best fit. So we're going to draw this straight line to connect to the line of best fit. So let's trace it upward. If we do that, let's do that upward. Yes, then you connect it to your vertical axis. Okay, connect it to your vertical axis. Let's do the same thing for vertical axis. You now draw and connect. Can you see that? If you look at this, it's not giving us a perfect line. So let's reconnect it. Let's reconnect. If we reconnect, it's giving us what you are seeing now. So our answer becomes 0.85 plus 2 gives us 0.87. 0.87. So when the mass was 180 grams, our T squared was 0.87. I hope you are following. Take note of this. It's not T inverse, please, but T squared. Is that clear? What are the precautions? Number one, I ensured that the G clamp was firmly clamped on the meter rule. Then number two, I avoided parallax error in reading stopwatch. Finally, bonus tip, WAEC NECO examiner tips. Use pencil for everything. Your graph, your labels, your line. Use a very sharp pencil. Never skip the origin. If the scale starts elsewhere, use broken axis. Is that clear? Label at least 3 to 4 values on each axis. Then ensure your graph is neat, is large, and readable. Okay? Then don't shade areas. You are not an art exam student. Take note of that. This is physics class. So that is that for this particular tutorial. If you enjoyed this tutorial, please, you can encourage us by liking this video and sharing with your friends, and also watching other tutorial videos. Thank you, and wishing you all the best in your exams. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.